through this chapter, we are sometimes going to use the word likelihood, and sometimes the word probability, and sometimes the word chance. It doesn't matter which one we use, the meaning is the same. We can indicate the likelihood, probability, or chance of a particular event happening by using percentage, fractions, or decimals. So we can indicate the likelihood, probability, or chance of a particular event by using percentage, fractions, or decimals. Okay, let's take an example for percentage. We can say, for example, that for each student there is a 80% chance of passing MIP 5 extended math. Here we indicated the probability or the likelihood or the chance in percentage. And when we use percentage, it must be between 0% and 100%. 100%. So between 0 and 100%. Let's take an example for fractions. Let's say that Rahul is firing arrows. And the probability that he hits the target is 15 out of 22. So 15 over 22. So the probability that he hits the target is 15 over 22. Like you can see, we expressed the probability in as a fraction, 15 out of 22. And the fraction must be between 0 over the denominator that you have here, 22 in this case, and the maximum, so 22 out of 22. And 22 out of 22. Okay, in this case it is 22 because the denominator is 22. When let's say the denominator was 15, then the probability must be between 0 over 15 and 15 over 15. Okay, let's take an example for the decimals. Let's consider Sophia, for example. Sophia dreams a lot during the math lessons. The likelihood of her paying attention is 0.5. The likelihood of her paying attention during the lesson is 0.5. So in this case, we expressed it as a decimal. And when we express it as a decimal, it has to be always between 0 and 1. In this chapter, we also make a distinction between experimental probability and theoretical probability. So experimental probability and theoretical probability. So when we are looking for the experimental probability, we do that by observing the results of an experiment. Of an experiment. And for the theoretical probability, we use arguments. So by using arguments of symmetry. Let's take an example for the experimental probability. So in the month December, we had 10 math lessons. So we had 10 math lessons. And Joshua asked in the beginning of 7 of the 10 lessons to go to the bathroom. So Joshua asked in the beginning of 7 of the 10 lessons to go to the bathroom. The chance of him asking this again will be 7 over 10. So the chance of him asking this the next lesson is 7 out of 10. How did I find this answer? I did that by observing the experiment. So the experiment in this case is the month December. So we had 10 lessons and Joshua asked in the beginning of 7 of the 10 lessons to go to the bathroom. So 7 out of 10. And we base ourselves on the results of this experiment. And that is the experimental probability. So an experiment happened and we used that information to calculate the experimental probability. While for the theoretical probability, we don't need an experiment. So there's no experiment. In this case, we use logics. For example, tossing a coin. So let's say we toss a coin and I ask you, what is the probability that it lands heads up? And you will answer 50% or 1 over 2. And you don't need an experiment to say that. You just use logics. So you use arguments. So tossing a coin, for example, the probability that it lands heads up is 50% or 1 over 2. And the probability that it lands tails up is also 50%, or 1 over 2. Another example, for example, rolling a dice. The likelihood of rolling a 4 is 1 over 6. The likelihood of rolling a 2 is also 1 over 6. So the likelihood of rolling a 3 is also 1 over 6. And you didn't do any experiment to say that. In that case, we call that the theoretical probability.